Hello, this is Algebra. We're in Chapter 7, Section 3, a new special number E, on page 1 of these notes. The box here near the middle of the page talks about the natural base E. Now, the natural base E is irrational. It's kind of like a square root of a funky number, that sort of thing. It's defined as follows. As n approaches infinity, 1 plus 1 over n, all to the n, approaches E, and that is approximately, well, it's about 2.718281828, and it looks like it repeats as a decimal, but actually it doesn't. It stops repeating after that 28 business at the end, so it actually is irrational, even though you might have said, oh, it repeats. Yeah, not really. Your calculator should tell you what E is, but you might need me to show you how to have your calculator tell you what E is. And if you need that help, I'd be delighted to help you with that. All right, let's look at example 1, where we have to simplify some expressions. Now, these look a little intimidating because it's like E's and numbers and stuff, but for this purpose, all we're doing is applying the usual rules. So, for example, on part A, where it's e to the 6th times e to the 3rd, it's really e to the 6th plus 3rd, because we're just adding exponents. So it's, e to the 9th. Done. Part B, 18e to the 6th divided by 2e to the 4th. Well, we're dividing. The actual numbers, the coefficients, divide, makes 9. And then the exponents of e subtract. So it's e to the 6 minus 4. So it's 9e squared. Part C says 4e to the 3x, all squared. Well, the 4 gets squared, and the e stays the same because it's the base, but the exponent multiplies by 2, because when you have a power of a power, the exponents multiply. So, 4 squared is really 16, and 3x times 2, 6x. 16e to the 6x. These are kind of basic exponent rules, very similar to the things you've seen in the last couple of chapters. Now, let's go ahead and look at example 2 on the bottom. The keystrokes that they show you here, these are for graphing calculators only. And I say that because they're just set up for doing it on a graphing calculator. But you do not need a graphing calculator to do these problems. You just need to know that if you don't have a graphing calculator, you should ignore those keystrokes. So for part A, for example, e to the negative 2, you're just meant to find some way of evaluating that on your calculator and getting a decimal approximation. And you should hopefully be able to get 0.1353352832. Boom. For part B, e to the 0.3, again, find a way of doing e to a power on your calculator. If you need help, let me know in class. I'll be delighted to help you out. But you get 1.3498588808-ish, give or take. And that's the end of page 1 of the notes. Thank you for watching.